I will do a bit of breaking, but let's at least do one or two more before we break. Then we went on to regression. Regression is something that I think also most of us, or at least the concept of having a scatter plot and putting a line or something in that, is something most of us were familiar with before coming to this class. What we may not have studied so much in detail before coming to the class is exactly how such a line actually is determined by the computer or the software that we're using. The least squares criterion, which fits the line with the minimum squared residuals, right? And that is an optimization problem in two variables from a mathematical perspective that can be solved easily. And the formulas for how to compute intercept and slope can easily be written out by simple formulas. Then we have some statistical modeling thinking behind it that may or may not apply in a given context. That's for us to think about, whether it makes sense to think like that. We need to think about uncertainty also when we do regression. What's the uncertainty of the slope computation, for instance? Next time I take a similar type of data, would I get the same slope, or how different would it be, right? How much value can I put in my slope computation? I'm going to use the slope, but is it really the right one? I should know about that if I'm an intelligent guy and I'm going to use this data for any important things in my company or research or society that I'm ruling or whatever I do. I need to think about that. So I gave you formulas for how to do confidence intervals and also hypothesis tests. These two go hand in hand now, if you want. For the individual's intercept and slope, and that can be combined into a confidence interval for the line. The line is constructed from the intercept and the slope, so we can find confidence interval for points on the line, and we can also find the prediction interval. The confidence interval is when we estimate, we use the line as an estimate of the mean of that subpopulation. The prediction interval is relevant when we would use the line to predict an individual person. Right? If you set up a system with either a camera vision system or a near-infrared spectroscopy system on your production line at Lundbeck or Novo Nordisk where the pills run through, and you use that to measure the individual pills, and then you want predictions for the individual pills. You don't just want to know the mean of all the pills. It's not good enough that the mean of all pills are on target. You cannot produce pills with just the mean on target. You must produce pills that each individual pill should be on target. Otherwise, your company will be ruined and people will be dead out there. So you need to predict the individual pill, and in such a case you need to do prediction interval for predictions to make sure that you're on top of uncertainty, and FDA and other regulatory agencies would require of you that you're able to do that in order to be allowed to do your production. So we distinguish between confidence intervals and prediction intervals. And then we had this R-squared thing that we are trying to explain to the high school community these days, what that really means and does not mean. Now this is a short version for you. It describes, the correlation describes the strength of the linear relation. The square of that can be interpreted as the amount of variability in the y that are explained through x and the regression model. So if that is high, it means that x explains a lot of what's going on in y, and otherwise, vice versa. It's all questions you've seen before, by the way. It's copies from previous lectures. Well, from a crowdsourcing perspective, okay. From a individual prediction perspective, so-so. Observations are independent. The errors follow the same normal. The actual y's, does not follow the same normal because the mean changes with x, right? So there's a different mean for the responses depending on which x you have. And the errors don't only follow a standard normal, they follow a general normal, right? Or with standard normal means a spread of 1. It's not all regression models in the world where the deviation is 1, right? It's a general sigma. So that was a bit of a trick question, but nevertheless, we need to check you. Hi there is doing well. Let's do the break. 15 minutes break now.